So good morning friends, welcome to Water Resources Engineering class. So right now we are dealing with the abstractions from precipitation. So in the abstractions from precipitation, we have already completed the evaporation and related items. And today's lecture is focused on what are the equations of evapotranspiration and what is potential evapotranspiration and actual evapotranspiration. First, I will take it very important. Please remember Blaney-Credle method. Blaney-Credle method is one of the most important methods for estimating the evapotranspiration. So, for this, what is the crux of the problem? Evapotranspiration is proportional to number one, daylight hours and mean temperature. Blaney-Credle have taken only these two factors as the major factors for determining basically the evapotranspiration. So in their point of view, what are the major points actually? Number one is the daylight hours, number of daylight hours. Number two is what is the mean monthly temperature. Based on these two, if you estimate the evapotranspiration, that is what Blaney-Credle method is. So what is that? So already data is known. What you need, daylight hours, how much you need, mean monthly temperature you need to know. These two if you know, then evapotranspiration becomes very simple. See the equation, the evapotranspiration is equal to K into F. Please note it. So this K into F, in this F only, all the factors are there. What factors will be there on this F? Number one is daylight hours. Number two is mean monthly temperature. These are the two items that will be there in that F. So F is a function of daylight hours and mean monthly temperature. Now I see instead of F what I have written, this is what we have written instead of. In that if you see what is the thing actually, this P represents daylight hours, whereas T represents what is fundamentally mean monthly temperature. So using those two, if you determine the evapotranspiration, we call it as Blaney-Credle method. Main thing is suppose if you go for any humid region or tropical regions, naturally this method doesn't work well because it doesn't take humidity into account actually, or wind speed into account, and it does not take into solar radiation. It directly takes only daylight hours how many and mean monthly temperature how much. Based on these two factors only this method works, but it does not take the humidity factor, it does not take the wind speed factor, it does not take the solar radiation. So that is what you need to remember. So based on that, the method is being explained clearly, stepwise you can see that, and then one problem also is taken, how to solve a problem using Blaney-Credle method. Please go through it. The second one is Penman method. Penman method is also very important method for determining evapotranspiration. On what factors this Penman method depends on? Number one is the energy balance. That is the first thing. Second one is the aerodynamic components. So what are the Penman's logic is what? Penman's thing is number one is energy balance. Number two is aerodynamic components. What is the energy balance? Means radiation. So this method depends on number one radiation, solar radiation. Number two is aerodynamic factors means wind and humidity. So this takes, because Blaney-Credle has not taken these three factors. Blaney-Credle has taken which factors? He has taken only daylight hours and mean monthly temperature. Now Penman has taken what? Penman has taken that solar radiation and also the aerodynamic factors which are wind velocity and humidity. So based on this, if we do it actually, we call that method as Penman's method actually. So in the Penman's method, the equations he has given it, you can see the equations, all the equations doesn't nothing but they reflect, one is radiation, they reflect, for example, this is net radiation that will be reflected, and also if you see it is the aerodynamic term is EA. EA is the aerodynamic term and Rn is the radiation term, and only thing is rest of the terms are only a padding of things. So this equation mainly depends on Rn and EA, that which we have done, and a small problem also to make you to understand the process which we have given it. So each term of the equation is also explained clearly. Please see that the evapotranspiration is a function of energy balance, which is solar radiation, and number 2 aerodynamic components, wind and humidity. That is the sequence of the Penman's method actually. The third one is Hargreaves class A pan evaporation method, and this method purely depend on pan coefficient, completely pan evaporation, pan coefficient. These are the two factors. Already anyhow you have measured the evaporation. So for that, what is the pan evaporation? If you give based on the pan evaporation, Hargreaves class A evaporation method is being used. This is it is Kp into Ep. What is Kp? Pan coefficient. What is Ep? It is pan evaporation. Knowing these two, we can find out what is the evapotranspiration. So these are the three methods. What are the three methods? Please tell me. One is Blaney-Credle method. Blaney-Credle method salient point is what? It depends on what actually? Tell me the factors actually for the Blaney-Credle method. Number of daylight hours, mean monthly temperature. Tell me the second method, Penman's method. Penman's method, which is important. Solar radiation is 1 point. The other points, aerodynamic components. What do you mean by aerodynamic components? The aerodynamic components are two. Number 1 is the wind, and number 2 is the wind, and wind velocity is number 1, which we have taken already. That is one which we have taken, and the other one is humidity. So these are the two things actually. Then coming to Hargreaves class A pan evaporation method, it depends on the pan coefficient. It depends on the pan evaporation. Based on these two, if you do it, this is the method. Now let me see the comparison between all the methods actually. So Blaney-Credle method, what is the main input? The temperature and daylight hours actually. This is the main thing actually. The complexity in this is nothing, only two factors actually. And it is moderate. Results are moderate. Mainly suited basically for the arid and semi-arid regions. What is the temperature required? What is the data required? One is the mean monthly temperature. Why this latitude is required? The latitude is only to count the number of daylight hours. So latitude is number of daylight hours. Temperature is mean monthly temperature. Knowing these two, Blaney-Credle method is being used. Coming to the Penman's method, number 1 is radiation, wind, humidity, temperature. These are the factors actually. Complexity is high. The more the factors you are taking into the equation becomes more complex actually. But accuracy is very, very high actually. And naturally, what we require data is full weather data. Full weather data in the sense complete data you require for this the Penman's method. What is Hargreaves method actually? It is only just pan evaporation. Accuracy is complexity is low, but if the pan is maintained very well, this also gives reasonable results actually. Pan data and pan coefficient. This is what which we require as far as these methods are concerned. The Blaney-Credle method, when only basic temperature, day length data, whereas Penman's method actually it is comprehensive, accurate climate data is required, then only this method is used. This is only pan evaporation data. If it is there, you can use this. So last point of this particular unit is what is potential evapotranspiration? What is the potential evapotranspiration over the entire country? That is number 2. Number 3, what is actual evapotranspiration? In what contexts we require to study these things. Let us come to the potential evapotranspiration. Very, very important actually for you. It is the amount of transpiration, or it is the amount of evapotranspiration that would occur from a reference surface, right, under optimal moisture conditions. Under optimal moisture conditions, please take it, the amount of evapotranspiration under which conditions? Optimal moisture conditions. There is no water stress at all. The water is completely filled sufficiently, and from there whatever evapotranspiration occurs, the maximum evapotranspiration that can occur is what? Potential evapotranspiration. Please remember, it does not depend upon the soil water availability. It depends on the atmospheric demand for the moisture. And please remember, it is the maximum possible evapotranspiration under ideal conditions. What is the importance of this PET? PET means potential evapotranspiration. India being agroclimatically diverse country, because if you see the entire country, the whatever the crops that which we grow are different, climate is also different, requires accurate estimation of PET. It requires for irrigation scheduling how much water is required for any crop at what time. That if you want to schedule it, naturally you require potential evapotranspiration. The planning of water resources. If any drought is there, assessment. Crop modeling, we require climate impact studies. Now I will explain more with respect to the PET behavior in various zones of our country. If you take an arid zone, actually, arid zone means especially deserts like Rajasthan, Gujarat, if you take it, there because of the very high radiation and high temperature, this PET range is very, very high. That means it depends on these factors. So the potential evapotranspiration is very, very high in this. If you go for semi-arid region, Punjab, Haryana, Deccan Plateau, if you take it, a little bit less actually. Whereas if you come to sub-humid region, not humid, so Uttar Pradesh, Madhya Pradesh, these regions, still lesser than the. If you go for humid regions, Kerala, northeast states, where rainfall is high, 800 to 1200. If you go for coastal means actually, naturally here also, humidity is more, Tamil Nadu, Orissa, West Bengal, around 1000. But if you go to mountains, Himalayas, less than 800. What it signifies, in the arid region, it is very high because of the high temperature. Semi-arid region, a little bit less. Sub-humid region, still less. Humid region, still less. Go to the coast. I am coming from Rajasthan to almost bottom actually. And finally, Himalayas if I take it. So these are the general pattern of potential evapotranspiration. If you see it, spatial variation of potential evapotranspiration. This is Thiruvananthapuram, if you take it, around 1200. From Thiruvananthapuram, you move upwards actually. This is Bengaluru, Chennai, a little bit higher than this. Go to Mumbai, a little bit still higher. You go to Kolkata, basically, almost similar. Go to Ahmedabad, Gujarat, still increasing. Go to Jaipur, Rajasthan, still increasing. Go to Delhi, almost similar. Whereas go to Srinagar, which is in the Himalayan range, it's very, very less actually. So this indicates how the annually the potential evapotranspiration, which is longitude, is with respect to the location actually. Latitude is with respect to daylight hours and temperatures, which we have taken actually. So this is what we want to mention. The highest PET is Western Rajasthan, parts of Gujarat and interior Deccan Plateau. lowest PET is Northeast India, Western Ghats and Himalayan region. And time wise, if you take it, April to June, summer, that is peak PET. The PET values are peak due to high temperature. Monsoon, naturally the PET values reduces during the monsoons. Winter, very low PET values actually. So depending on the season and depending upon the location, spatial. So in space and with time, how they change actually. Highest value of PET which we record generally will be in Dhart is at around 2200 mm per hour, whereas the lowest PET is in the Himalayas and the northeast region. So kindly remember why all this is given is potential evapotranspiration is something actually which is the maximum possible evapotranspiration under ideal conditions actually. And one more also, this is the amount of evapotranspiration that would occur from a reference surface. Please remember the reference surface is always known a well watered grass that is being taken as a reference actually always under optimal moisture conditions but no water stress at all. And what is the basically how the PET behavior changes actually? Arid regions it is very high, and from there if I go to coastal it goes on decreasing, and especially Himalayan region it is still lesser actually. The values also, if you want, the PET value varies spatially and also temporally. Spatially means, for example, highest value is in the western Rajasthan, parts of Gujarat. Lowest is the northeastern India and western Ghats. Whereas temporal variation is summer month, the PET value is very high. Whereas if you take it monsoon period, a little bit lesser, and if you go for winter, still lesser. So this is what basically the potential evapotranspiration and its how it is being observed across the country. That is what we have given. Then what is actual evapotranspiration? Actual evapotranspiration is the actual amount of water transferred from the land surface to the atmosphere. How much is the exact amount of water that is being transferred from the land to the atmosphere is what we call it as this. Always remember that the potential evapotranspiration is higher than the what you call it as actual evapotranspiration in general actually. So potential evapotranspiration means the amount that could occur under unlimited water supply, and whereas this AET is often less than PET in arid and drought prone regions where soil moisture is limiting. So India has again a diverse climate ranging from humid to humid tropical in the south to the northeast to the arid semi-arid in the west. This diversity leads to significant spatial variation of AET. So western Himalayas, if you take it, naturally like PET, AET is also very less. And as you move basically towards upper side, how it is increasing also you can see it. Actual evapotranspiration. So how to get the sources of actual evapotranspiration? ISRO is one source, Indian Meteorological Department, and NRS National Remote Sensing Center is the other thing. Based on these three things, this AET is obtained. What for AET is required? Mainly again same. It is mainly water resources management, agriculture and food security, hydrologic modeling, and climate change the impact studies. Actual evapotranspiration is the key indicator of water use, how much, the agricultural health and ecosystem function of in India. Whereas understanding this is required, why understanding of AET is required is to manage water, land, agriculture more sustainably, especially under climate stress conditions. AET is more important under water stress conditions, whereas PET is naturally the maximum evapotranspiration that can occur. So differentiation of these two is very important actually. With this, we close this lecture. Thank you so much for your patience. Thank you.
Vishnu Audio Visual Center. Like and share and subscribe and click bell icon.